Good morning, good day, good afternoon, good evening, good night, whenever you're listening to this. As you can see on the screen here, there's a Khan Academy video playing that I'm going to talk over. Of course, you can see at the bottom of the screen there are captions that are related to the video. And this video is in our course playlist. I have put together several videos and resources on our course playlist on Moodle for your benefit. As you know, this is an online asynchronous course, and you need to be self-motivated when you study the material indicated on Moodle that will be used for the quizzes and exams. So today I'm going to talk about this idea of measures of central tendency and measures of variability. They are the two broad aspects of descriptive statistics. And as you might recall from the previous video and your readings, descriptive statistics are necessary to do in order to do inferential statistics. So we will be moving on in this course to discuss inferential statistics, but first we have to do descriptive statistics. It's absolutely necessary. So think about making macaroni. You need macaroni noodles and you need cheese. Absolutely need those two ingredients to make macaroni. So you need descriptive statistics, you need measures of central tendency, and measures of variability or dispersion. As you might recall from last week, we have the mean, median, and mode are our three averages. So the word average no longer means what you think it means. Now, average means mean, median, or mode, and the mean means the average, if that makes sense. It will make sense if you review the course notes and the material in the textbook. So the arithmetic mean, you might already know. You've probably calculated this in grade school, junior high, or high school. This is where you add up all of the numbers that you have in a data set and you divide by the amount of numbers that you have. We have a nice, neat equation for this. This is explained many different times through many different resources all across the internet. So keep in mind that if you ever have a question about any concept or procedure in this course, you can ask me, but I'll likely point you towards our textbook, the course notes, our course playlist, or I can type in the word or the concept into YouTube or the internet search engine that I use and find resources for you. These are all very basic. This is an introduction to statistics course. So we start off with this very basic idea of adding together all the numbers in a data set and then dividing by the amount of numbers that we have to come up with the mean. And again, you need to remember that the mean is probably what you still think of as the average, but we have three different measurements of central tendency that refer to the average, which is a number that best captures the entire group of data points or the data set that we're interested in. So you can see on screen here, the presenter has added together 1, 1, 2, 3, 4. There are 5 numbers divided by 5. The average number is 2.2. You can see in that data set, there is no 2.2. Like 2.2 does not exist in that data set. The 2.2 is a constructed number that represents the entire group. It doesn't represent any particular individual or data point or case in the group. It's an important point to keep in mind because when we're doing statistics, we're oftentimes producing numbers that represent a large amount of data, 30, 50, 100, 1,000 different cases. And you have to remember that there's lots of variability. So the measure of central tendency that you use, the mean, median, or mode, will represent the middlemost number. We also have to have measures of dispersion or variability that represent all the different numbers that exist within a data set. So in this case, it's 1, 1, 2, 3, 4. There's a lot of difference there. So the range is 3, the difference between the highest and the lowest. But sometimes we want to know like what the average difference is of all the numbers. And that's what we refer to as the standard deviation, which is covered in chapter 3 of our textbook. So we're going to move on in that direction. Just in this case, know that the course playlist on YouTube that I have curated for us has videos like this that will go into depth and explain in more detail the information that I have in our course notes, which is derived from our course textbook. It's very readable. And if you don't master the ideas and concepts and procedures in chapters 2 and 3, then you're going to be lost probably for the rest of the semester. Chapters 2 and 3 are very important, especially chapter 3. So in chapter 2, the ideas might be familiar to you, this idea of average, mean, median, mode, that we have 3 different ways of measuring an average. The median is the middlemost number. The mode is the most often observed number. Like in this case, 2 is the middlemost number. We have an odd amount of numbers, so 2 is 1, 2 from the lowest, 1, 2 from the highest. It's the middlemost number. We might want to use that, especially in cases of extreme scores or outliers, when you have a very, very large number that really skews the data off towards that large number. A mode is the most popular, the most often observed number. And there are definitely situations where we have to use mode. We cannot use the mean or the median because what we're observing are simply the frequencies of the amount of times that we observe something. So imagine in this situation that we're looking at individuals' attitudes towards chocolate ice cream. And we say, on a scale of 1 to 5, what are your thoughts, feelings, or tastes or preferences on chocolate ice cream? And mysteriously enough, there are 2 people who have very low opinions. They say, well, I'm a 1. One person's allergic to it. Another person just doesn't like it. Another person is kind of indifferent. They say, I'm at a 2. Another person says, I'm at a 3. Another person says, I really like it, not as much as peanut butter, so I'm at a 4. So we observed 1 the most amount of times. So in that situation, maybe it's the frequency of the categories that we see and not really the average number that we see in terms of the mean. Maybe in that situation, we'd want to use the frequency of observations as opposed to the mean, which can have problems, especially in cases, as you see on the screen, where there's an extreme outlier. Like the mode in this situation is 3. The median in this situation would be 3. The mean in this situation, as we'll shortly as calculated, is 19 and 1/6. So which measure of central tendency should you prefer in this situation? Well, probably something that represents most of the numbers, or the most frequently observed numbers, or data points, as we'll call them, and not something that is skewed towards the outliers. That idea of skewness will become very important when we start looking at the normal distribution. The normal distribution of the bell curve is where we're leading to when we think about measures of central tendency and measures of variability. And it's the normal distribution that allows us to jump over into doing inferential statistics. So those are the types of things that I'm going to talk about. Welcome to the course playlist. This is linked to on our Moodle page, and I just want to show you something real quick. So the video that we just viewed in the background is placed right here. Khan Academy statistics, the average, descriptive statistics, probability and statistics. This is right in a location where I have several videos on the very same thing. As I was saying, there are many, many resources that you can find on any topic covered in this class. If you're ever confused about anything, just type it into your favorite search engine, whether that's on a browser or within YouTube, and I am positive that you will find help on it. The recorded videos for this semester will be at the bottom of this playlist. So the video that you're watching right now is located as an embedded video on our Moodle page, but also they're at the bottom of our course playlist. So you might want to bookmark this playlist if you're ever out waiting in line somewhere and you want to use your time wisely and watch one of my lectures. Okay, welcome back to our Moodle homepage. As you can see, and as you might remember, here are where the important documents and links are, including our course textbook, the student resource site for the course textbook, and the course video resources. This would be the YouTube playlist. Okay, you should by now have watched our first video, our second video, and after this video is posted, it'll be right here in week 3. So let's just go ahead and open up the notes for quiz 1 and test 1 that are placed in week 1. And as you can see, we're picking up right where we left off last time. So there are 4 scales or levels of measurement. These are really important to know. This is super important stuff. Why? Because when you collect or analyze data, the data must be at the interval ratio level of measurement in order to calculate the mean. You must be able to calculate the mean in order to do inferential statistics. You must be able to calculate the mean in order to calculate what's called the standard deviation. The standard deviation is kind of a tricky concept, but you can get it if you work on it. This is covered in chapter 3, and we'll be looking at this in our next video. I want you to look right here on your screen at this symbol called X bar. That symbol refers to the mean. As you recall from our previous video, there's 2 different means. There's the sample mean and the population mean. And in inferential statistics, remember, we are taking a sample from the population so that we can infer to the population. So we have a sample mean and a population mean, and they have different scientific or statistical notations. Most of the time we'll be dealing with the sample mean, but do keep in mind that there are symbols that represent the population mean. Those will become important when we start diving into hypothesis testing. But for the time being, see the symbol X bar here. A little bit larger, it's right here, X bar, and there's a calculation, the sum of all of the data points, X, divided by the number of data points that we have. You've probably done this many times already in your educational career. So as I was saying earlier, though, we will be moving on into looking at what's called the normal distribution or the bell curve. So if you calculate the measure of central tendency called the mean, it'll be right in the center most of the time. Most of the time, it'll be right in the center. And this is the product of the calculation from what's called your raw scores, your actual data. What the standard distribution does, what the normal bell curve Gaussian distribution does, is it allows us to compare different raw scores in a standardized way. And the way that we do that is with what's called the standard deviation. I'll be getting into this in more detail, but I want you to see right now the relationship between the mean and the standard deviation, that we're going to apply them to the standard distribution or the bell curve. So once again, you can see the symbol for the mean is X bar. We use it as a measure of central tendency in the normal distribution, and there's something called the standard deviation. Now, back to the standard deviation. You can see that inside of the maybe complex, scary-looking equation is X bar. So the mean is a part of the mathematical equation for calculating the standard deviation. Therefore, you must be able to calculate the mean to calculate the standard deviation. Therefore, you need both the mean and the standard deviation in order to utilize the normal distribution, which allows us to be able to make comparisons and inferences from samples to populations. This is why it's super important to understand levels of measurement, because you absolutely must have an interval ratio level of measurement in order to calculate the mean. On page 54 and page 55, you'll see that the author of your book has introduced you to the formula for calculating the mean. This material is indicated in the reading list that is associated with quiz 1 and test 1, as seen here in week 4. And so this is assigned reading material. The book is very readable. It's designed for this level of a class. You need to review the course notes, which are directly associated with the textbook, and you need to follow along with these video lectures where I show you where the important information is. Like page 65, where you're introduced to this idea of scales of measurement or levels of measurement. These are directly associated with measures of central tendency. The scale of measurement tells you which data you can and should use. So what that means is that if you have nominal level data, which is data that refers to names or categories, like a student ID number is a number, it's numerical data, but it doesn't represent any numerical value. It's just a number associated with a name. Kind of like if you have political parties, or if you have religious affiliation, or marital status, or gender, or race, or ethnicity. These are categories. We can count the number of times that we see those categories, or we can associate an ID number with a name, but that's about all we can do. That's at the nominal level of measurement. The ordinal level of measurement is one level higher. This is the level of measurement in which you'll have first, second, and third, or rankings. You'll have differences in preference, such as like attitudinal scores for preference of chocolate ice cream. Do you like it 1, 2, 3, 4, or 5? We don't know the real distance between a 1 and a 2, or a 2 and a 4. Apparently, seemingly so, 2 is twice as much as 1, and 4 is twice as much as 2. But think about it. If somebody indicates that they have a level of 4 on a preferential scale for chocolate ice cream, does that really mean that they're twice as much as a 2, or 2 is half as much as a 4? Can you like something twice as much as somebody else? You can spend twice as much money. Maybe if you have a 4 level of attitudinal preference for chocolate ice cream, you're willing to spend twice as much money as a 2 level. But think about this. Somebody who indicates a 2 compared to a 1, are they willing to spend twice as much as somebody who never buys chocolate ice cream? If somebody buys 0 amounts of chocolate ice cream, can you buy twice as much as them? So you have to be careful with what numbers represent in statistics. If the information or the concepts that I just presented to you don't make much sense, I'll review them, but you can also check out many other resources on the internet. Here, I've typed into my favorite search engine the key concepts that I want to know about. Here, I've clicked on the images, and as you can see, there's plenty, tons, many, a myriad, there's a plethora of images indicating that this is a well-studied, well-covered topic for educational purposes. Here we have an image with several little images in it indicating the different types of levels or scales of measurement. At the nominal scale, this is where you'd fill out a survey and indicate your demographics. So your sex or gender, your race or ethnicity, your nationality, your marital status, your educational status, these categories that you would be a part of that have names that we can observe the frequency of. Ordinal would be like whether or not you have differences in tastes or preferences, or how much of something there is that really has no degrees between the differences, such as like hot, hotter, and hottest. If you go outside and you ask somebody like, how's the weather today? Say, oh, it's hot. Does that really tell you much of anything other than somebody thinks that it's hot? So something could be colder, something could be hotter, but unless we have particular measurements like Celsius and Fahrenheit, we don't really know what the difference is in the intervals. So when we measure like Celsius and Fahrenheit, we have different degrees. So for example, like Celsius goes from 0 to 100 between where water freezes and water boils. Fahrenheit's not like that. Fahrenheit is a measurement where water freezes at 32 and boils at 212. Very different scales of measurement, but the intervals in each measurement are exactly the same. So one more way to measure is with a true 0 point. So this would be like Kelvin, where there's no below 0 in the Kelvin scale. So this shows you that there are different levels of measurement. So you can jump from level to level. Ratio would be the highest level of measurement, but oftentimes interval levels of measurement are perfectly fine. Those are the ones that we need in order to calculate the mean, because those are the levels of measurement where numbers actually have inherent value, and there's an actual difference between numbers where there is twice as many of something as of something else. At the nominal and ordinal levels, you cannot have that. If you come in first, have you come in half as much as second? That would depend upon the actual time that it took you, for example, to complete a race. If you completed a race in 2 minutes, whereas the next person in second place completed it in 4 minutes, you did come in with half as much time as second place. But first place is not half as much or twice as better as second place. So This is a quick demonstration of measures of central tendency, how they relate to measures of dispersion or variability, with the mean being necessary to calculate the standard deviation, and how the measures of central tendency are related to scales of measurement. So in the next video series, we'll pick up on this.